Okay, so here's another problem, and it's basically the setup is the same as the previous one that we did, but here we're going to find a force on the 5 microcoulomb charge instead. Okay, so the process is going to be very similar. Okay, however, there are a few additional things that we must find. Okay, so let's first begin with our with everything that we need. Now in this case, what I would recommend is that since we are not finding the force on the charge at the origin, okay, we know that the forces are not just going to be left and right, up and down. Okay, we're going to have angles in this thing. So before you do anything, it would be good to just figure out what angles you may need. So okay, so ask yourself, in what direction is the 10 microcoulomb going to exert a force on the 5 microcoulomb? Okay, that answer is easy. Okay, and if you said that the 5 is going to experience a force to the right, then everything is good. So due to the 10, the 5 experiences a force to the right. We'll just call it F1. Okay, on the other hand, due to the -2, alright, let's figure out the force. Now what we know is that these forces are always along the line joining the 2 points. So if I were to connect the 2 points, okay, we'd end up being along this line. So now we ask the question, in what direction along this line is the force exerted on the 5? Is it towards the -2 or away from the -2? And that's basically what you have to ask. So clearly in this case, the 2 is negative, the 5 is positive, the negative attracts the positive, and as a result the force on the 5 will have to be in this direction. So once you identify this, okay, once you identify the two forces, it becomes very clear what angles you need, because we're going to need the angles in order to figure out the components of the vectors appropriately. Okay, so in this case clearly we need to know this angle, so this angle theta, and we can find this angle theta very easily, okay, using basic trigonometry. We have a right angle triangle, and the angle theta can be found using basic trigonometry. What we know is that if you look at this triangle, tangent of theta is equal to 0.2 divided by 0.5, which happens to be 0.4. okay, and this gives us theta as tangent inverse of 0.4, which happens to be equal to about 21.8 degrees. Okay, so now we know the angle, so everything should follow in a straightforward manner. Also we know the quadrant, and in order to figure out the quadrant, again what I recommend is go to the chart that you're interested in, draw a little axis there, and then get all your quadrants relative to that axis. Okay, so in this case clearly F1 is pointing to the right, and then F2 is pointing along the southwest quadrant. Okay, so that will give you the correct signs for its components. Alright, now that we've set up the base for the problem, let's figure out the individual forces. Okay, so the force F1, the force between the 10 and the 5 is going 10 and the 5 is going to be equal to 9 times 10 to the 9 times 10 times 10 to the -6 times 5 times 10 to the -6 divided by 0.5 square. Okay, calculate this number, see what you get. So it's going to be equal to 1.8 newtons pointing to the right. Okay, so we can find its components. Alright, so the components are going to be equal to 1.8 comma 0. Note again, when I write my components I put the vector sign on F, and when I write my magnitude I do not have the vector sign. So just it's something that you must try to keep track of. Okay, let us repeat the process for F2. The magnitude for F2 is 9 times 10 to the 9 times, it'll be 2 times 10 to the -6 times 5 times 10 to the -6 divided by, now here we have to ask what distance are we going to have to take, and it is going to be the distance between the two charges. And if you look at the picture, the distance between the two charges can be found easily using Pythagorean theorem, which is going to be equal to 0.2 square plus 0.5 square under root and you will end up getting it's square root of 0.29, so I'm just going to leave it as square root of 0.29. The reason is because I'm going to square it, so I don't have to worry about it. So it'll be so the denominator will end up being equal to square root of 0.29 square. Okay, so this gives us the magnitude. Let's calculate this number. So this happens to be equal to 0.31 newtons. So we now have the two forces, 1.8 newtons, 0.31 newtons. However, we got to figure out the components of F2, and F2, since it is in the third quadrant, is going to be equal to negative 0.31 times cosine of the angle we got is 21.8 minus 0.31 sine 21.8. Okay, so now that we have this, let's figure out the individual components. So that happens to be negative 0.287 or 288, and then the other one happens to be negative 0.115. Okay, so now we have F1 and F2. We can figure out F net. F net is equal to F1 plus F2, and F1 we said was 1.8 comma 0 plus F2, which is negative 0.28 comma negative 0.115288 comma negative 0.115, and this gives us 1.512 comma negative 0.115. Okay, now I can find my magnitude. The magnitude is equal to square root of 1.512 square plus 0.115 square. Okay, so which happens to be equal to this plus it's about 1.516 newtons, and the angle theta is going to be equal to tangent inverse of 0.115 divided by 1.512. Okay, and that number is going to be equal to about 4.35 degrees. And again, we have to figure out the quadrant, and to figure out the quadrant we look at the signs of the x and the y components. The y is negative, the x is positive. If y is negative, we have south. X is positive, it's east, so we have southeast. Okay, so understand the process here. So in this problem, in order to figure out, okay, we needed to figure out the correct angle, okay, whatever the angle that we were going to use, and then we also needed to figure out some lengths that were not directly given in the problem. Okay, so it's an involved problem. The steps are essentially the same as all the previous ones. Find the individual vectors, and then once you have the individual vectors, add them up using vector algebra, and then everything should flow from there. Okay, so I hope this one helps and that you're able to do some more problems. In fact, a challenge would be not a challenge, just to test yourself. It would be a good idea to go ahead and figure out the force on the negative 2 microcoulomb charge. So do that problem and see what you get, and make sure that you understand all the steps involved in the problem. Okay, perfect.